Hello everyone, my name is Avinash from Mechanical Regular. Today I am giving a presentation on the topic sources. First, let us understand the term sources. Sources uh, is a device which converts mechanical, thermal, chemical form of energy into electrical energy. It is an active element in the electrical circuit which main function is to produce electrical energy. Uh, there are main two types of sources. One is the voltage source, another is the current source. The voltage source has a producing function of EMF, and the current source has a function of producing current. And each source is further subdivided into two classes: ideal and practical. And the voltage source, in coming to the voltage sources, a voltage source is a two-terminal device where the voltage across the two-terminal device is constant, independent of the current drawn from it. And voltage source at that type is called an ideal voltage source. Practically it's not obtained. And voltage source which has some internal resistance is called as a practical voltage source, due to which there will be a voltage drop, and a resistor is connected in series with the voltage source, and that is termed as a practical voltage source. An ideal voltage source, the impedance or resistance will be zero. And my topic is current sources, so I'll be covering current sources in detail. So coming to current sources, the current sources, as I mentioned below, it has a function of producing current with an input as voltage. And the current source is further classified into ideal and practical. This is the representation of the current source. And an ideal current source is a two-terminal circuit element which supplies the same current to any load resistance connected across its terminals, and it does not depend on the voltage of the source terminals. It has infinite resistance. So the main difference between a practical current source and ideal current source is that the resistance is connected in parallel for a practical, whereas for an ideal current source there is no resistance. And that's the main difference between an ideal and a practical current source. There will be a drop in current for the practical current source due to the resistance connected in parallel. And this is the graphical representation of an ideal versus a practical current source. As you can see, there is a drop in the current in the practical current source due to the internal resistance, and for an ideal current source, the current is independent of the voltage. And whereas in the case of the practical current source, it's not. There will be a drop in the current due to the internal resistance which is connected in parallel with the current source. And coming to the next topic, the source transformation. Source transformation simply means replacing one source by its equivalent source. Like the practical current source can be replaced by another practical voltage source, and vice versa. The practical voltage source can be converted to the practical current source as well. So an ideal voltage source, or simply a voltage source, is a practical voltage source is an ideal voltage source connected with a resistor in series, and the impedance is zero in case of an ideal voltage source. Whereas in the current source, or simply a practical current source, it is an ideal current source with a resistor in parallel, which has impedance infinity. So those are the definitions of a current source and a voltage source. For a voltage source, when the impedance is zero, it is termed as an ideal voltage source, and the generators, AC regulators, all this comes under a voltage source. And semiconductor transistors, which produce current, are termed as current sources from the output. Depending on direct or alternating source, they are termed as direct and alternating current sources. So these source transformation is possible, and we'll understand how this exactly takes place with the help of an equations. And you can see in the circuit diagram as well how an practical voltage source is converted into an practical current source. So moving ahead, these are the equations for a practical voltage source. Okay, the load current will be given by the equation ILV is equal to V RV plus RL. The ILV means the current drawn in the load current for a practical voltage source B, and V is the voltage, RV is the internal resistance, and L is the load resistance. And in the second equation, it's replaced by practical current source. Is Li is the load resistance, it's a load current for a practical current source, and I is a current circuit, and Ri is the current, is a internal resistance of the practical current source, and RL is the load resistance connected in parallel with the current source. When we equate 1 and 2, we find the sources identical. When it's simplified, we get the equation RV is equal to RL, which means the resistance which connected in series with the practical voltage source is equal to the resistance connected in parallel for the practical current source, which is equivalent. This is better understood with the help of this circuit diagram, the conversion of voltage source into current source. When both are equated, the practical voltage source with internal resistance R is converted to a practical current source with load resistance R, which is equivalent to the resistance connected in series in the voltage source. So for a practical voltage source with voltage V and internal resistance R is converted to a practical current source with current I, and the resistance connected in parallel is equal to the internal resistance of the voltage source. This is a circuit diagram. When the voltage source is connected with the resistance series, it has to be converted into the current source, and the resistance is connected in parallel with the current source as shown in the above diagram. This is represented as where IS, the current, is equal to the voltage by the resistance. With this, we covered the topic, the sources, and we understood what's the difference between a voltage source and current source, and how they are transformed from one form to another. And by this, I end this presentation. Thank you.